Okay, so I looked through this question and I've decided that it's valuable for me to go through it. So because I'm recording this, I'm going to try my hardest to not make it a long video. Okay, so this is something that we've already done, and it's a different form of question of one that we've already done. Okay, so it says here the diagram represents the graph of f of x and g of x. Okay, points A and B are x-intercepts, and f of x, and point C is the y-intercept, and yeah, okay, whatever. The x-intercept of g of x is at point L, the y-intercept is at point Z. The graphs intersect at points R and F as shown. Okay. So it wants us to determine the length of AB. Okay, so let's find out where AB is. AB is this line across from the two x-axes, or the two x-intercepts of our parabola. We can see that graph is a parabola. Okay, so what that means is all we need to do is we need to find the x-intercepts and then figure out the distance between them. Okay, because that's what the length of AB is. It's the distance between our two x-intercepts. So let's figure out our x-intercepts. Okay, so we're given the function for a parabola. Okay, minus 6x minus 20. Okay, so you can factorize this, but I just prefer using the quadratic equation. But I'm going to use a calculator just to keep things short. Okay, so 2 minus 6 and minus 20. Okay, that gives us an x-intercept of 5. Okay, that's an x. 5 or negative 2. Okay, so what is the distance between 5 and negative 2? Okay, so this takes a little bit of understanding, but obviously the x-intercept at point B is equal to 5, and at A is negative 2. Okay, so over here, this distance here is 2 units, and this distance here is 5 units. Okay, so 2 plus 5 equals 7. And if we scroll down, we can see that the distance is 7 units. Right, so that's that first question done. Nice and easy, nice and simple, but I can see that they're going to get harder because they have a line graph and all of that. Okay, so determine the coordinates of the point R. If we look on our graph here, we can say that R is the intersection between our parabola and our straight line. Okay, so that's actually nice and easy to figure out. So what do we know about the point R? Okay, we know that the x values and the y values at point R are the same. Okay, for both our parabola and our straight line. So what that means is that our graphs are identical at point R. So all we need to do is we need to equate our graphs and solve. Okay. Okay. So we equate our graphs and now we solve. So let me solve quick. So that's going to be minus 9 and minus 11 equals 0. That's 9x. Okay. So again, I'll use the quadratic equation just because I prefer it. Okay. And we get a point 11 over 2. Okay, these are x coordinates, so x equals 11 over 2, or x equals negative 1. Now, we need to use a little bit of analysis. We have a point 11 over 2 and a point negative 1. And if we look here, our graphs are at the same value on 2 points, at point F and point R. Now, we use our logic and we choose the negative x value because obviously this point is to the left of our x-axis. Okay, so we have our x value for R over here. So now we need to find the y value. So it's going to look like this. Okay, x and the y that we need to find. Okay, so what do we need to do is we need to take this x value and we need to put in one of our functions. It doesn't matter which function, we just need to put in one of them. So I'm going to choose the simpler one, which is the straight line graph. Okay, so y equals -3 minus 9, y equals -12. So we get our coordinates, -1, -12. Okay, and if we go down here, we can see that is exactly what our point is. Right. So, next question. Okay. Given that OP equals 3, okay, so OP, O is at the origin, okay, so that's what they mean when they talk about O. So, what we know is that this distance here is 3. Okay, so given that OP equals 3, and OP is perpendicular to TPQ. Okay, TPQ, perpendicular. Okay, perpendicular means that there's a right angle, okay, which there is. We can see it there, it's 90 degrees. Okay, TPQ is just a line. Okay, it's just this line here. Okay, with T on f of x, okay, T on f of x, that just means it sits on the graph. T on f of x, and Q on g of x. Okay, Q on g of x. Okay, figure out the length of TQ. Okay, so this is a nice and easy question. So, we already determined that P is at 3 because from the origin it is 3 units. Okay, so the value at P is going to be -3 and 0 because it's on the x-axis and it is 3 units from the origin. So it is going to be -3 and 0. Right. So what do we need to figure out? We need to figure out the length of TQ. Okay? So we need to figure out this. Okay? And what can we see? We can see that T is a point on f of x and Q is a point on g of x. So all we need to find is the y value of T minus the y value of Q. That's all we need to find. So this is also a very nice and easy question. Okay, so let's figure out the y value on the parabola. Okay, so we get -3 squared minus 6, -3 minus 20. Okay, so that is going to be equal to 18 plus 18 minus 20, which is equal to 16. Okay, let me make sure that's correct. Okay, it is. Okay, so the value at t, the y value, or actually the coordinate is going to be -3, 16. Okay, now what we have to do is we have to find the value at q. Okay, so we just use our other graph, g of x. Okay, g of x is equal to 3, -3, minus 9. Okay, which is equal to -18. So, again, we use our logic to figure out the height. This is 16. That is 16 units. This is 18 units. Okay, so what is 16 plus 18? It's 34. Okay, so that is the height or the distance between our 2 points. And that is question 6. And you can see, or question 5. Okay, you can see that it's very quick, very easy. It honestly, it didn't take much calculating at all. And yeah, it was completely manageable. And I managed to get through it quite quickly. Cool, bye.